Welcome to next lesson in relativity. Today we will discuss another consequence of the Lorentz transformation, which is popularly known as twin paradox. This is a famous thought experiment in relativity. Thought experiment means a hypothetical experiment. Here there are two twin brothers, and originally they are on Earth, so they will have the same age. And suppose they made a spaceship, and one of the two twins travels in the spaceship near the speed of light, say to a distant star. So what happens? So there are two frames of reference. There is one frame with respect to the Earth, or with respect to the brother who is remaining in Earth. And the second frame is the frame of the spaceship, that is the frame of the brother who is moving to the distant star. So according to special theory of relativity, it predicts that the moving clocks run slow. So according to the brother remaining in Earth, he will say that the clock of the brother moving in the spaceship is slow. So when the clock in the Earth records say 10 years, then the clock on the spaceship will not be showing 10 years, it will be showing less than 10 years. So he will say that is the brother remaining in Earth will say that his twin brother who is moving in the spaceship is younger than him. So that is one consequence of the time dilation, because the moving clock runs slow. The faster you travel, the slower the time passes. So this is the description of this paradox with respect to the observer on Earth, or with respect to the brother who is remaining in Earth. But in relativity, there is no absolute frame of reference. All inertial frames of reference are equivalent. So everything is relative. Now if we view the problem from the perspective of the spaceship, that is with respect to the frame of reference of the second brother who is moving to the distant star, we will see that everything is in the opposite sense. So with respect to the brother moving on to the distant star, the Earth is moving in the backward direction. So he will say that the clock on the Earth is running slowly, and he will claim that the brother who is remaining on Earth will be younger than him. So both of them, each of them would think that the other person's clock is slower, and each brother claims that the other is younger than him. So this is a paradox. The question is, what happens if the twin brother comes back to Earth? So after that long journey, he come back to the Earth. When he comes back to the Earth, what will be their age? Whose clock will be really going slower? So this is a paradox. This seems to be a paradox, but there is no paradox here. On a close inspection, you can see that the brother who is remaining on Earth is always in an inertial frame. Inertial means the Earth is not accelerating. If we neglect the acceleration of the Earth due to its rotation, then the earth can be taken as inertial frame. But the brother who is going to the distant star will experience an acceleration while he is starting the return journey. When he is going to the distant star, he is in an inertial frame, and while returning he experiences an acceleration, so the frame is not inertial. Then he is coming back to the earth with a constant velocity, then again it is inertial frame, but that inertial frame is another inertial frame. There are two inertial frames, so he is claiming his result by measuring from two different inertial frames, and in between these two inertial frames there is a small region in which he is experiencing acceleration. So his frame is not an inertial frame of reference, so his claims cannot be tolerated. So answer is the clock on the spaceship will be slower in time. So the man in the spacecraft is experiencing acceleration, so his frame is not inertial, and his claim that the other clock is slow is not correct, because the special theory of relativity is valid for inertial frames of reference. So we can say that the one who feels the acceleration is the one who is younger at the end of the trip. Hence the brother who travels to the star is younger. And this is a thought experiment, and this type of real experiments are conducted by using clocks on different spacecrafts and air flights also. And this time dilation experiment is experimentally verified. And remember, there are many explanations for this twin paradox, and this is the simplest one, and you can see many other explanations. Thank you for watching this video.